With the rapid development of economic construction, there is a sharp increase in the demand for electricity in society. This has led to higher requirements for energy efficiency, reduction of losses, fire safety, stability, reliability, environmental compatibility, and convenient installation of power transmission, transformation, and distribution equipment. JST self-developed liquid immersed transformers stands at the forefront in the industry, boasting features such as energy efficiency, environmental friendliness, reliability, and intelligence. The offshore wind turbine transformer digital factory is located within JST Wuhan Intelligent Green Industry Park. The Wuhan factory is the third-generation digital factory constructed by JST after the ones in Haikou and Guilin. It has been identified as a major project in Wuhan City. The Wuhan factory provides customers with voltage levels up to 145 kilovolts and capacities up to 60 MVA of synthetic ester, natural ester, and mineral oil immersed transforms. These transformers have extensive applications in various fields, including new energy, high-end equipment, industrial electrical support, traditional power generation, and power transmission and distribution. Wind turbine transformers can be customized and designed according to customer requirements. Compared to traditional mineral oil immersed transformers, ester-based insulated transformers not only have higher fire safety and environmental performance, but also smaller sizes with outstanding overload capabilities. As a result, they have gradually become a development trend in the field of wind power. The Wuhan factory provides onshore and offshore wind turbine liquid immersed transformers with built-in nacelles or tower compartments to support wind turbine manufacturers. These transformers are designed to complement units ranging from 5 megawatts to 20 megawatts. Currently, the company has successfully developed onshore wind power solutions with ester-based insulated transformers for capacities exceeding 7 megawatts as so far. Additionally, for offshore wind power applications, solutions for 16 megawatts and 18 megawatts have been achieved. Prototypes have undergone third-party testing, including short-circuit tests, temperature rise tests, vibration tests, and withstand pressure tests, among others, to validate their performance. The transformers have obtained relevant international certification from entities like DNV and other certification authorities. Through the integration of smart technologies and information management, the factory strives to optimize production processes, improve efficiency, and stay at the forefront of industry innovation. The iron core automatic cutting line can process silicon steel sheets as thin as 0.18 millimeters, with a burr thickness of less than 0.02 millimeters. The winding workshop is equipped with 9 5-ton vertical winding machine stations. There are 2 3.5-ton horizontal self-loading wire equipment stations. Additionally, there are 24 5-ton horizontal winding machine stations. Furthermore, there are 3 double-layer foil winding machine stations. The 4.5 kilowatt winding assembly platform is equipped with an electrically adjustable height feature. There are 2 sets of vapor phase drying systems with capacities of 200 kilowatts and 300 kilowatts. These systems have adopted jet heaters to replace traditional internal wall heaters, resulting in improved drying efficiency. There are 2 sets of 80 cubic meter hot air circulation vacuum drying ovens, which are capable of meeting the coil drying capacity for the annual production of 1,000 units. There are 4 sets of 200-ton constant pressure drying devices, and each set can simultaneously compress multiple coils. There are 8 elevating active part assembly platforms that can simultaneously handle the assembly work for 4 units. The automated guided vehicle automatic feeder can carry a maximum load of 30 tons and autonomously execute instructions, meeting the requirements for product transformation and transfer. There are 3 sets of independent insulation liquid treatment systems. These systems enable unmanned operation and intelligent quantitative injection of insulation liquid. There are 2 sets of 30 kilowatt mobile vacuum filtration systems, capable of simultaneously performing vacuum extraction of insulation liquid and thermal circulation immersion on 4 units of products. The fully enclosed shielded digital test lab is equipped with power equipment of voltage level up to 145 kilovolts. It has a complete set of testing capabilities, including power frequency withstand voltage, lightning impulse, partial discharge, temperature rise, and noise tests. The Transformer Intelligent Test platform allows for one-time wiring to complete all routine tests except partial discharge. The insulation liquid physical and chemical laboratory is capable of performing gas chromatographic analysis of insulation liquid, measuring dielectric loss, determining water content, and conducting withstand voltage measurements. Digital Intelligent Three-Dimensional Warehouse directly receives logistics tasks issued by users, improving production efficiency. In the field of transformer research and development, a digital design capability based on PLM system and 3D design software has been established, enabling full lifecycle digital design. It possesses simulation capabilities in electric field, magnetic field, temperature field, and mechanical structure. It meets the increasing demands in the rapidly developing wind power market. It marks a significant milestone for JST in the progress of the new power system, symbolizing a new chapter in the journey towards advanced equipment manufacturing in the high-end sector.